Are you having trouble getting your AI systems to deliver dependable and credible results? I'm Rob Llewellyn, and today we're going to tackle a critical topic, which is implementing quality assurance in AI pipelines. Quality assurance in AI pipelines refers to the process of ensuring that AI systems produce reliable, unbiased, and explainable results by validating data, evaluating model performance, and continuously monitoring production systems. So when it comes to AI, quality isn't just a nice to have. It's a business imperative. Unlike traditional software, AI systems don't give you a simple pass or fail. They give you probabilities, patterns, and predictions. And without proper quality assurance, those predictions could lead to costly mistakes, reputational damage, or even compliance issues. But don't worry, today I'm going to walk you through how to implement robust QA processes that make your AI systems not only powerful, but reliable. So let's break it down into 3 key pillars for success. First, we need to understand why QA in AI is fundamentally different from traditional software testing. In a typical software environment, you probably know you have clear, deterministic outputs. The system either works as expected or it doesn't. But in AI, it's not like that. AI systems produce probabilistic outputs, meaning that they don't always give the same answer for the same input. And because AI models learn from data, the quality of that data also directly impacts the model's performance. If your data contains bias or errors, the model will inherit those issues. This is why QA for AI must go way beyond just testing code. It needs to encompass data validation, model evaluation, and continuous monitoring in production. For example, a leading healthcare provider I worked with discovered that biased training data caused their predictive model to favor certain patient demographics over others. By improving data validation and retraining the model, they significantly reduced bias and improved trust in the system's recommendations. That brings us to our second key pillar, which is building a comprehensive AI QA framework. Now, this framework should cover 3 main areas: data quality, model quality, and pipeline quality. So for data quality, focus on validation, cleaning, and ensuring that your data represents the real-world scenarios your AI will face. You also want to monitor for distribution shifts, where the data your model sees in production differs from the data it was trained on. Next, model quality involves more than just tracking accuracy. You need to assess robustness, how well the model performs under varying circumstances. Fairness is another critical factor. Ensuring your AI doesn't produce biased or unfair outcomes. And don't forget explainability, making sure your AI's decisions can be understood by humans, especially in high-stakes environments. For example, a financial services firm I spoke with improved explainability by using model interpretability tools. And this allowed their compliance team to understand and audit AI-driven credit decisions, ensuring regulatory adherence. Finally, pipeline quality is about ensuring the entire end-to-end process is reliable. And this means having proper integration testing, version control for data, models and code, and setting up robust monitoring and alerting systems for when things go wrong. Now, the third pillar is integrating QA throughout the AI lifecycle. Because QA isn't something you just do and forget. It needs to be embedded at every stage of development, deployment, and production. During development, you need to ensure you have unit tests for data pre-processing and robust validation techniques for models. In the deployment phase, you need to consider staged rollouts or A/B testing to mitigate risks before a full launch. And once your system is in production, continuous monitoring becomes critical. You'll want to set up alerts for performance drift when your model's accuracy begins to degrade, and have incident response protocols in place for very quick action. Now let's talk about tools. There are plenty of tools, of course, that can help automate and streamline your QA efforts. For data validation, tools like Great Expectations and TensorFlow data validation can help save countless hours. For model testing, frameworks like MLflow and weights and biases are excellent for tracking experiments and performance over time. And don't forget about custom monitoring solutions that can be tailored to your specific needs. Of course, even the best tools won't help if you fall into common pitfalls. And one of the most frequent mistakes is overlooking data quality. Too many teams focus solely on the model without realizing that flawed data leads to flawed predictions. Another common issue is insufficient edge case testing. Your AI might perform well in 90% of cases, but those rare scenarios can cause serious problems if not handled correctly. For example, in one project involving autonomous vehicles, insufficient edge case testing led to failures in rare weather conditions. By expanding their testing to include more edge cases, the team significantly improved system reliability. Lastly, inadequate monitoring is also a pitfall that often leads to undetected performance issues. Without proper monitoring, you won't know when your model's performance starts to drift. And if you want your organization to excel in AI quality assurance, you'll need to build a culture that prioritizes quality. And this means defining clear roles and responsibilities for QA, establishing review processes, and continuously training your teams on the latest best practices. Remember, AI is constantly evolving, and your QA processes need to evolve with it. If you're ready to take your AI efforts to the next level, check out the links below for tools, templates, and resources that can help you. Thanks for watching, and I'll see you in another video.